Hello, all. Hope everyone is doing fine and welcome to this session. Today, we will explore how generative AI in maintenance for automotive manufacturing. We will look at the journey from downtime to data driven uptime. This presentation will highlight key concepts, technologies, and implementation strategies. The automotive factories constantly struggle with unexpected equipment breakdowns that halts the production line and creates substantial unplanned equipment expenses. Emerging generative AI can definitely provide a solution to bridge this gap by decoding complex signals and data coming from sensors on the production line and analyzing that information to create some fruitful results, which we will look at in details as we move through this product presentation. So, with that note, let me move forward. Now, quick introduction about me. I'm Abhijit Joshi. I'm a supply chain transformation specialist. I'm currently working at Deloitte Consulting, and I have total 20 years of experience in leading digital transformation initiatives across different automotive manufacturing clients, as well as I have also worked in other industries. I specialized in data-driven operation excellence and predictive maintenance solution. Through my journey of 20 years, I have seen multiple different implementation for maintenance, and as a first-hand experience, I started my career with the maintenance module in the manufacturing industry. For 5 to 6 years, I have had hands-on experience in the maintenance situation for my old company. And then I moved to the ERP consulting. So that was just a quick introduction about me. Now let's move forward, jump into the concept and understand what we are trying to achieve through this. Now, here is the abstract and overview. Now, what challenge we are here to solve today? Now, based on the recent data, unplanned equipment downtime cost automotive manufacturers up to 22,000 per minute as in loss. And the traditional manufacturing strategies are inadequate to address this challenge. Now, what is the solve, which we're going to see through this presentation? Now, with recent AI developments, applying generative AI to predictive maintenance in ERP system can reduce your plant downtime by 40%. This session explores the approach of how any maintenance application implementation can leverage this, how AI can help to analyze data provided by sensors on the production line. And this data is arranged into a structured workflow pattern can fed into a maintenance system to generate the preventative maintenance work order. So that's the solve which a new technology can bring in. Now, as we move forward, we will see what are the different ways of achieving this outcome. Now, there are a few more points where this advanced computing system identify early signs of deterioration that are often missed by a standard monitoring equipment or even by a human interaction. There is a chance it can be missed. Now, car manufacturers integrating this capability directly into their enterprise resource planning system, which has fundamentally changed used to create the work order in order to act on these problems. So, with that note, let's move forward and see that how we can go through this journey. Now, let's talk about the traditional maintenance methods. Typically, there are three ways of handling maintenance: calendar based maintenance, usage based maintenance, or condition based maintenance. Now, even if we take our day to day examples, like having your own car, it needs a maintenance. So, you can either go by one of these three methods. During my visits to different industry, these are three methods which I have extensively seen getting used in the traditional maintenance. Whether it's being a manufacturing plant, it's being oil and gas refinery, these were mainly three interfaces. Now let's talk a little bit about them. When we say calendar based, it's a fixed interval that after 3 months, I'm going to do some 1, 2, 3, 4 activities for this specific piece of the equipment. What are the challenges? It can be premature, it can even miss expected failures because you are just following a time. You're not looking, was the machine utilized enough in this time period? Now, next is a usage base. Now, maintenance based on some run cycle or a count to better understand how long it has been used. So, after that specific time, you do the maintenance. Again, this is not a right way of doing a maintenance. Third is the condition base. Let's say you monitor some parameters and based on certain life of that parameter, you create work order. So these are three typical traditional maintenance methods. Now let's move forward and look at what are the challenges of this traditional maintenance method. First challenge is this is the reactive maintenance. This is not a proactive approach. So the traditional maintenance system is basically reactive in nature, that based on certain problems, you try to solve the problem. And it is very much disruptive to the production lines and the production flows. Then there are fixed schedule limitations. So there could be a chance that equipments are serviced too early or too late. And it's also a wastage of resources and risking of failures, which is a typical challenge of the traditional maintenance. And third, and the most important, is lack of data driven decisions. So the moment we say we are doing it by fixed time interval or calendar base, we are not utilizing any past data, which is a typical challenge. Now let's move forward and see, is there any way we can convert this reactive into proactive approach? Now this slides talks about that how we can convert a reactive approach into a proactive approach. And that is what the maintenance team needs, which will help them to proactively use, to rightly use their resources. Now, generative AI plays a vital role in this transformation. It can transform maintenance from reactive firefighting to proactive optimization through a data-driven insight and predictive analysis. Now, let's see how can we achieve this. So, typically, there are three drivers for the approach which we are proposing. So, one is the IoT. Now, when I say IoT, it's Internet of Things. It's a kind of bridge between what is happening at the equipment versus how it can translate to the signal, a kind of transducer what we had in the earlier ages. So one of the driver to achieve this proactive approach is the IoT integrations, where your equipment will talk and generate a data signals. The second driver is the ERP. Now, typically most of these industries, a car manufacturing industry, have some kind of system behind the scene which tells them how much is their inventory, what is their work order, how many times they have to do a certain kind of activity in terms of maintenance of that equipment. So these are handled through a ERP system. And third is the generative AI. Now, generative AI is the most important driver out of all this, which sits on top of IoT and ERP to generate the result. Now, we talked about the three important drivers in this approach. Now, let's move forward and look at what framework we are suggesting in order to move reactive to proactive approach. Now, generative AI for predictive maintenance framework. If you see on your left hand side picture at the top, that we are suggesting that let's collect the data from different sensors. Look at your maintenance history. See your performance metrics. Now you have this huge data. Now this data has to be fed and analyzed before sending it to the ERP system. So ERP should get the important data which it needs to do certain actions. Now GenAI engine comes next to this. It sits on top of ERP where it analyzes that data and give ERP a signal rather than some predefined. It tells that, hey, this is the time that you have to create the maintenance work orders. These are the times based on the equipment deterioration or the capacity it has been utilized, you should be performing your maintenance. And that is what goes to your manufacturing system within ERP, and that generates the real-time information. Now, there are possibly three actions which can happen of this system. One is automated action, which is creating a maintenance work order, which tells technician that he's supposed to go and do a maintenance on this particular equipment. Secondly, deriving a plan becomes a very optimal because now you can plan your future work order based on your downtime of the machine. Third is generating multiple KPIs out of this information. So this is the approach which we are proposing, which can convert your reactive maintenance into a proactive maintenance. Now let's move forward and see what is the role of each of these components in this. So the first is IoT, Internet of Things. Now, what is its role? Its role is to collect the data from all different production lines. Imagine you're working at the car manufacturing facility and you have tons of data coming from everywhere. Initial stage from building a different parts till the last stage where you do a painting of your car. There is a lot of robotics used in this production line. Given the demand which this industry is seeing, there is a lot of automation happening on each of the phase of manufacturing. This automation definitely triggers a lot of information, which is basically a Internet of Things, where you collect all that sensor information and translate into a respective signal. So if you look at the 3 points mentioned here, real-time sensor data. So sensors embedded in the machine captures the real-time data, such as vibration, temperature, pressure. It assesses the entire equipment health. Analysis, analytics foundation. This collect is provided to analyze that information. Continuous monitoring. IoT networks provide continuous monitoring, which is not possible for any human. So that is the first aspect and the role of the IoT. Now let's move forward and look at the second important component in this workflow, which is ERP. Now, what is the role of ERP integration? Like I mentioned before, ERP is used for having all different aspects of the company, whether it's a purchase order, production work order, or your inventory. So apart from creating a maintenance work order, it also facilitates a data which is required to fulfill that work order. What parts you need, what instructions are there for performing that operation or maintenance, and what resources you need. So the idea here is IoT provides that information to ERP, and rather than having a traditional engine of preventative maintenance based on the calendar, it reads that data and try to generate a work order if there is a situation where maintenance is required. It can predict that ahead of a time based on the current equipment health. So if we read through the 3 points here, which is the predictive maintenance management, this is the ERP system management module. Automated work order generation. ERP automatically creates a work order and allocates the resources when AI detects any potential issues. And continuous improvement feedback. ERP feedback refines AI module, improving predictions and the accuracy. Now let's look at the third aspect, the role of generative AI, which is the most important aspect in all these three parameters. Now what AI does, AI is modeling equipment behavior. It generates the equipment behavior to understand and predict the potential failures. Secondly, synthetic data generation. It generates a synthetic data scenario to simulate different operational conditions for the analysis. It also keeps learning based on the real-time data. As we have seen, IoT is constantly providing our data. Now, generative AI has capability to self-learn from the history as well as with the new data which is coming and understand the failure pattern. Third is proactive maintenance forecasting. Based on a data it's reading, it can forecast what are the maintenance need. It's not just about maintaining any equipment, it's also about making sure you have enough to perform that activity. You have enough resources there at the right time to execute that activity. So GenAI can perform all that activity behind the scene. So we have looked at the three aspects of this process and what is their role in performing this operation. Now let's move forward and see that what are a target application which we think. Again, the possibilities are endless, but we think that these two are very important applications within the car manufacturing, like the robotic system and the paint application line, where the solutions can be implemented. Because these are the most prone things in the process which can lag the productivity if there is a maintenance failure. So, early failure detection in automated assembly and welding robots through continuous monitoring of operational patterns. This can be achieved through generative AI with the continuous monitoring. Paint application lines, predictive maintenance for paint booth equipment and spray system to prevent any quality issues and any downtime. So these are some target applications. Now let's see what is our implementation strategy. Now this is pretty high level view of the implementation strategy. Definitely if you are running any pilot program, you have to have much details. But we categorized into three steps. One is leveraging existing infrastructure. So the point here is, do I need to create the entirely new infrastructure or I can leverage existing? So answer is you can leverage your existing infrastructure. Use your current sensors, your data. The only thing is now it will go to a certain data warehouse where it will get analyzed and translate into a readable format. Now step number, integrate predictive intelligence seamlessly into existing workflow and create the preventative work order and assign them to the technicians. So you can start leveraging your data. Third step is scale gradual adoption. So the approach we are trying to suggest here is go stepwise, do a phase wise approach. If you have 10 plants, go with one plant first or possibly even a one product line so that there are minimum disruption to the existing process. And once you prove your result, then you can move to a larger scale of implementation. So once you implement this strategy, what are the results you can expect? Somebody can ask that, okay, I'm implementing this, but what are the results? So we have studied this implementation across the industries, and these are some proven results from the deployment. Again, it will be vary for some of the companies versus other, but this is a kind of ballpark which we can expect. So your downtime reduction should at least go to 40% because now you have put intelligence into the system, which will help you to reduce unscheduled downtime. Secondly, forecasting accuracy. Now, the earlier forecasting was based on the calendar dates. Now you are using system intelligence to do a forecasting. So definitely we see around 85% improvement in that accuracy. Your equipment deterioration is utilized to predict what maintenance you need. Third is reduction in the false alarm. With the traditional method, you can do a maintenance based on again the calendar days, right? So there could be a chance of the fall. Now with AI integration and the pattern recognition, it can reduce to 50%. Now when we say we have this fabulous result from our deployment, definitely what are the outcome in terms of cost and efficiency I can measure. So again, we did study based on our prior implementation, and these are the results we see. Again, just a call out. This may not be specific to one client to other. It is based on what is the expected outcome, a kind of ballpark. So your maintenance cost should reduce by 30% by optimizing scheduling as well as resources. And secondly, since you have lot of historical data from the prior corrections, even if there is some first time fix rate, it should be improved to the 90%. That is what we expect as an achievement to this implementation. Now let's move forward and see what are the key benefits we are getting with this implementation. So one is plant repairs. Now since you have intelligence, you can very well plan your maintenance schedule without pausing instead of emergency shutdowns. So you reduce your emergency shutdowns due to the better monitoring of equipment. You enhance the reliability. So transform maintenance into a strategic driven of production stability. Third is a cost efficiency, which we have seen on the earlier slide, that you achieve significant cost saving to optimize maintenance operation. So there are multiple benefits of having this implementation, but these three we see as most prominent benefits from performing this reactive to proactive transformation. Now, the next slide and the concluding slide in this discussion is what should be our vision if we implementing and if we are on the journey of implementing this methodology. Our vision should be zero downtime factory vision with growing Gen AI acceptability across multiple industries and even in the car manufacturing industries that serves as a core enabler to achieve this zero time downtime factory vision. Even the future automation system, we can expect that they will self-diagnose, self-repair, and enhance the reliability and the cost effectiveness. So with that note, let me thank to everyone for listening and giving me your